Hello, and welcome to today's webinar, 5 Things Sassy Covers That SD-WAN Doesn't. My name is Elva Betzig, and I'm the VP of Product Marketing here at Cato Networks. A couple of housekeeping items before we get started. You're welcome to submit questions at any time using the chat window on the right-hand side of your screen. We will follow up with you after the webinar if we don't get a chance to reply to your questions live. We'll also make a recording of this webinar available to you within a couple of days. Now let's get started. The first item, which I call the obvious one, is that SD-WAN traditionally lacks security, which SASE does offer. I want to start with kind of using this star illustration to describe an enterprise network. It has all the edges of the enterprises. We see on-prem DCs, branches, remote users, cloud DCs, and the internet. It obviously needs a network to connect all of them together, and it must be secured, right? We don't want to allow free access from the internet into our resources, between users to resources, and from resources to the wide world of the public internet. The challenge is that SD-WAN traditionally lacks the security. So what we would see in a common situation is that we'll see SD-WAN appliances in physical locations. We'll see a virtual SD-WAN in the cloud data centers, and they would form our wide area network. And then we'll see additionally next-gen firewalls, virtual and physical, in the physical data centers and the cloud data centers to secure internet access. As a result, remote users as well as branch users are backhauled into a central security location or security inspection point at a data center to secure their internet traffic and their access to corporate resources. And this backhauling loads the data center firewall and connectivity, as well as degrades the performance of the users and the applications. So that's a big problem. Now, there is a promise in cloud security that will keep our virtual wide area network overlay with SD-WAN as is, and we will add what is called today an SASE that will take over internet and cloud security from us. It would allow remote users, branches, as well as physical location to securely connect to the internet and the cloud. The problem with this solution is that you would still need your next-gen firewalls to provide east-west security and govern access to corporate resources. And as a result, your security is fragmented. And fragmentation is what creates blind spots and misconfiguration that later on leads to cyber attacks being able to succeed in attacking your networks. So the ultimate solution here is to actually use a SASE platform that delivers unified security everywhere. All the edges are connecting to a single unified SASE cloud, either with a SASE edge, which can be like an SD-WAN appliance, a SASE client for remote users, and a virtual edge for the cloud data centers. The benefits here is that security is unified. That means that the same security is available everywhere. There is no need to backhaul users or traffic anymore in order to have them pass through the same security stack. And as a result of that, fragmentation of the security solution is also eliminated. So that's one thing that differentiates SASE and SD-WAN. Here's a quick poll for you folks on the webinar today. How far are you from refreshing your wide area networks? Options are, I just did it last year, we are on it right now, I'm planning to do it later in 2023, or this is a much later in 2024 project or even after that. Okay, I can see the results coming in. Super, so we have about 20% who did this already last year, and I think nearly 60% are going to do it sometime this year, and a few of you are planning to do it in 2024 or after. All right, let's move on to the second difference between SD-WAN and SASE, and that is that SD-WAN can't replace MPLS. Traditionally, it was thought to be able to serve as an MPLS replacement, but for a large portion of the cases, it is not a real viable solution, and here is why. If you look at the ISP network through which you are connected, it looks something like this. You are here, and you go through the ISP network that has multiple layers, the access layer, aggregation core, and the transit layer. Within the ISP network, routing is completely under control, and that allows the ISP to guarantee network performance within the network. But once you get out of the ISP network into another network, whether it's another ISP or the internet, routing is under control. And not only that, the really available bandwidth is really what you see here at the top of the pyramid as a very small portion compared to the bandwidth that you have at the edge of the access layer. So let's understand what this means when you're trying to connect two sites that are distant from each other, or a user and resources. So the user is in one ISP network. The resource is connected through another ISP network. Within those networks, the routing is under control. Once it gets out of the network, this is where we're starting to see the combinations of bottleneck, congestion, jitter, and packet loss. This is the result of unpredictable routing and unreliable performance that are what drives the business for MPLS. MPLS provides a predictable and reliable connectivity between any two locations around the world, at least in theory. The problem with MPLS, as everybody knows, is the cost and rigidity of the solution. However, SASE with the global private backbone can be very helpful in this case. Let me show you how. The user is in one network, the resource is in another one, routing is under control inside the ISP network, and also under control outside of the ISP network as it rides the private backbone of the SASE provider, which controls routing and guarantees performance beyond your local ISPs. So this is another place where SASE has an advantage over SD-WAN because it can actually replace your MPLS circuits. So speaking about MPLS, let's do another quick poll. Are you still using MPLS? Options are, yes, we are and we love it. Or, yes, we are and we hate it. No, we are not. Or, what is MPLS? And this is for the latest and most new organizations in the world. Right, so I see that almost 45% are having it. Some love it, some hate it. Some do not have it, and very few don't know what MPLS is. I believe if we do this survey in 2 or 3 years, the share of people who say what MPLS is will be far greater. Ole, let's continue. The third difference is the frustrating one. SD-WAN can't get you to the clouds, and the SASE can. Let me explain. When we look at branch to cloud or user to cloud, the connectivity is non-trivial. There are a few options to go about it. 3 of them are suboptimal for cloud DC access connectivity. So let's take this example where we have 2 branches and a data center, for example, at AWS. We can use an expensive private link like ExpressRoute or Direct Connect, but this link, which is very reliable and expensive, terminates at the physical location, which means we will need to backhaul traffic into that location in order to benefit from that link. And we already agreed backhauling is not a good option. The second option is connect directly over the unpredictable internet. That would give me a so-called direct access to my cloud resources, but it's insecure and it's unreliable, thanks to the transport being completely unpredictable. If I want to have some more predictability and control over this transport, I can do this by using an edge SD-WAN in my physical site and a virtual edge SD-WAN on my cloud site. But even in this case, there is some improvement, but since your cloud data center and your edge branches are not running on the same ISP, you would still fall into the same problem that we showed earlier when connecting 2 physical sites, that once you get outside of your ISP network, traffic is out of control and unreliable. Similar problems apply to accessing cloud applications, not only cloud data centers. They also suffer from the problems of unpredictability or partially predictability access options. Let's look at this example. I can connect directly from the branch to the cloud applications, and it would be unpredictable. So if I'm running any form of latency sensitive or jitter sensitive applications in my cloud applications, then the unpredictable internet would degrade the performance dramatically. What I can do is to route my traffic through some regional hub using SD-WAN technology from my physical location to the physical data center, and from there a short connection to my cloud application. But building all those regional hubs wherever your cloud applications are is not really a viable solution. The real viable solution is actually to go with a SASE platform. A SASE cloud will get you to your clouds very easily. It can connect any edge to any cloud, and it has all the built-in optimization and security that you need. There is end-to-end cloud-based optimization. So all your edges connect to the nearest SASE POP, and all your cloud data centers and cloud applications connect to the SASE POP that are closest to them. This gives you predictable edge-to-edge cloud routing, right? So we can always control and make sure that the traffic is going over a reliable transport for the majority of the path. It also eliminates the need to subscribe to premium connectivity or to build dedicated hubs, like we've seen as some of the options in the previous slides. And it's available everywhere, and there is no need for backhauling as we support branches and remote users directly from the SASE cloud. So as you can see here, a SASE cloud actually solves all your cloud connectivity options, both for cloud applications and cloud data centers, in one shot. So, quick poll on cloud connectivity. How are you connecting your clouds to your wide area network today? Options are IPsec over the internet, virtual SD-WAN over the internet, a private cloud connector, or I don't have any cloud data centers yet. Okay, a few more seconds to let the answers come in. And I can see that most of you are using IPsec over the internet or a private cloud connector. Some are still using virtual SD-WAN, and nobody said they don't have cloud data centers, which is also a cool thing. Let's continue. Number 4, which I call the annoying, is that SD-WAN won't help your remote users and SASE will. I think this was very dominant during the pandemic, already 3 years ago, when COVID-19 broke and we all realized that the infrastructure that we had wasn't sufficient to sustain an immediate transition to work from home. But let's dig into the details around this. SD-WAN really can't help remote users. Direct cloud and internet access is not secured and is not optimized. We've already established that. The alternative is to backhaul the traffic into a VPN concentrator and from there go out into your cloud data centers. In this entire drawing, you actually don't see a single SD-WAN appliance because none of this traffic has to go through SD-WAN, not from physical sites to cloud data centers or not directly over the internet to cloud applications. So in either way, SD-WAN has not contributed to my needs of connecting remote users. However, a SASE platform can do that very efficiently. In fact, remote users can actually be first-class citizens in a SASE cloud deployment. So the VPN elimination can happen with client and clientless access. We won't need any VPN server to backhaul into and from there to get to our destination. It will happen straight from the end user, either using a client or a clientless browser access. Everything is optimized for wide area network and cloud access, as said, without backhauling. So all the users go directly to the cloud, to the nearest SASE POP, and from there over the SASE backbone to the destination. Full security and inspection is applied to all traffic, which means you don't need to, again, route the traffic manually through a specific cloud firewall or physical firewall or any inspection point to make sure your users have the same security when they connect from remote as when they work from the office. So here you can see how well SASE can help connecting both remote users and office users to wherever they need to get on a single platform, which SD-WAN can't. Another quick poll on that. How are you connecting your remote users today? Options are using a legacy VPN server or concentrator, using your on-prem firewalls and their remote VPN connectivity options, using a cloud-based ZTNA solution, or using a cloud-native SASE. So results are coming in, and I can see that the majority are still using legacy VPN servers and concentrators, few are using on-prem firewalls, some with ZTNA, and very few have yet to transition to a cloud-native SASE, but this is exactly what we are here to discuss today. So let's go to the fifth and maybe the most irritating point about SD-WAN versus SASE is that SD-WAN won't save you money, where SASE surely will. At the beginning of the SD-WAN, many of us were led to believe that by moving away from MPLS to SD-WAN, we will be saving a lot of money. In practice, this was not the case, but in fact, what happened is that cost was, or that spend was optimized So the same money that we spent on 10 megabits of MPLS would now allow me to buy 100 megabits with 2 internet transports and an SD-WAN solution. Obviously, the cost per megabit per second is much lower, but we need much more bandwidth because of the migration to cloud and the more excessive use of cloud applications and internet access. So we couldn't save on the network. Where can we save? So if we look at what an IT infrastructure looks like today, it's comprised of the network transport we spend money on, the network stack, security cloud, and the mobile stack and their management. SD-WAN is actually just one piece in a much greater IT infrastructure of security cloud and mobile solutions. And for all those different components, as IT teams, you are forced to go through vendor evaluation, procurement, integration, maintenance, and troubleshooting every time you want to refresh any one of those pieces that you see here on the slide. That is costing you a lot of money in time, resource, effort, and sometimes even frustration around so many procurement and integration projects. However, if you look at it from a SASE perspective, one SASE cloud can replace all those components. So effectively, you have just one platform to evaluate, procure, integrate, maintain, and troubleshoot. That means that you save a lot of money, mostly in people's time spent on all the work of procuring, integrating, maintaining, and troubleshooting all the different point products, which you now replace with one. So you won't save money on the cost of your network infrastructure, but you can save a lot of money just by avoiding all those repetitive cycles of procurement and integration with so many point solutions. I'd like to close this part with a quote from Gartner. And it's always good to listen to the analyst more than you listen to the vendors, obviously, because we are not objective, nor we pretend to be. This is what Gartner said. By 2025, 50% of new software-defined wide area network purchases will be part of a single vendor secure access service edge or SASE offering, which is a major increase from 10% in 2022. The same quote or the same prediction appeared both in Gartner's Magic Quadrant for SD-WAN in September and in Gartner's Magic Market Guide, for single vendor SASE. What this effectively means is that all the points we went through in the first part of this webinar are all summarized in this quote from Gartner. The market, the buyers are shifting from buying SD-WAN as a standalone solution into buying it as part or a feature of a single vendor SASE platform. Because of all the reasons that we've mentioned, because SASE can eliminate MPLS, it has the security built in, it can connect your clouds and your remote users without compromising on performance or on security, and it can help you save money, not on the network, but on other aspects of your running your IT on a day-to-day basis. So, one quick poll before we continue. Would you like to hear more about Cato Networks and Cato SASE Cloud? Options are yes, please, or no, thanks. Wow, that's a lot of options to choose from. I already see some answers being typed in the chat window, which is great. I'll try and address all of them towards the end of this webinar. All right, so the majority of you wants to learn more about Cato, so let's do that. So let me give you a quick overview of Cato Networks SASE Cloud. Let me start at how it works at a high level. Cato connects all your branches, users, applications, and clouds into one global cloud-native network. So all the traffic is optimized end-to-end between users and applications, literally everywhere in the world. Next, Cato protects all traffic inside its cloud service against threats and attacks with a full security stack. So there is enterprise-grade protection that is applied to all traffic across data centers and branches and down to a single remote users or a mobile device. And finally, customers have flexible management options. You can either manage all network and security policies and access full real-time analytics from a single self-service console, or use a co-managed or fully managed service from Cato and its partner. It's really that simple, but let me tell you about it in a bit more details. Before we go into explaining how the cloud or the Cato SASE cloud actually works, in order to deliver a Cato SASE, a SASE platform solution, you need a global footprint of POPs or points of presence to deliver a converged network and security capabilities everywhere. At Cato, we deployed over 75 POPs globally, and we are adding several POPs every calendar quarter. The Cato SASE Cloud, as you can see, covers the major business locations, including the Americas, Europe, Middle East, the Asia Pacific, and China. You can always see the latest list of our POPs on our webpage at status.catonetworks.com and see where are the POPs that are closest to your business locations. So let's take a closer look at the Cato SASE Cloud. At the core, we build a global private backbone of POPs that run our converged software stack. The POPs are interconnected with redundant Tier 1 providers that provide consistent and predictable long-haul latency, jitter, and packet loss. The POP software selects the best route across providers for maximum uptime and best end-to-end performance. This design offers an immediate improvement in network quality over the unpredictable public internet and a significant cost reduction per megabit per second over MPLS. This is the backbone that allows you to get rid of your MPLS circuits when you move to an SD-WAN that is part of a SASE platform. Inside each POP, we run our single-pass cloud engine software, or SPACE for short, that performs all the networking and security processing in the cloud. The SPACE is built from two parts, a multi-gig packet processing engine and a real-time policy enforcement engine. The SPACE is natively built to process multi-gig traffic flows from all enterprise edges, including branches, users, devices, and applications. It automatically extracts rich context from each flow, including the user identity, device posture, target applications, and data files. It finds the best route for the traffic and applies protocol acceleration to minimize round-trip times. Decryption is applied as needed without any impact on the user experience. So as you can see, all the traffic gets all the network processing and optimization that is needed to optimize traffic to wherever it needs to go. Multiple security policies are uniformly enforced through SPACE. Firewall as a service provides end-to-end segmentations of traffic. Secure Web Gateway protects users against phishing and malicious websites. And intrusion prevention systems and next-gen anti-malware stops advanced threats. ZTNA provides secure remote access, and CASB DLP controls access to risky cloud applications and prevent sensitive data loss. All these capabilities run on all the traffic at the same time to minimize security overhead and leverage the rich context extracted for every packet. So unlike the first case that we saw where SD-WAN is lacking security, here the network and the security are truly one software stack. Customers connect all network edges to the cloud using secure tunnels. Physical locations connect via Cato Secure Socket Edge SD-WAN devices. The Cato socket manages multiple last-mile connections in active-active mode. It moves traffic to the best path based on the underlying link behavior. The socket also applies quality of service prioritization based on application and user awareness, and it protects critical applications like voice against packet loss. Cato provides a broad set of policies out of the box that optimize traffic for the most common requirements with the ability to configure highly granular policies for your specific needs. Cato sockets also support site-to-site MPLS and internet connection for regional use cases and for bandwidth-intensive applications with low security exposure like backup. Customers that already have other SD-WAN or don't care for Edge SD-WAN capabilities can establish IPsec tunnels from existing devices to the nearest Cato POP and get the network and security benefits of the backbone with a zero on-site footprint. A remote user uses a Cato client or a browser to securely connect to any applications on-premise or in the cloud from laptops, tablets, and smartphones. The users dynamically reconnect to the nearest POP as they move from place to place, and traffic is consistently optimized and secured as they go. So as you can see here, in this case, remote users are in fact first-class citizens on the network, and as they move from the office to a remote location, they would still go through the exact same SPACE engines and ride the exact same global private backbone and get full security and optimization to access whatever they need to get to. Cloud data centers connect over a standard IPsec tunnel or using a virtual software connector, a virtual socket, provided by Cato. The cloud data center becomes an integral part of the network, and its traffic is optimized and secured in the same way as all other traffic. So there is no need to deploy virtual firewalls, as Cato provides the full visibility and control over both outgoing and incoming cloud data center traffic, and optimization, which, like we said earlier, eliminates the need to subscribe to private cloud connectors. For public cloud applications, no integration is required. Optimization, inspection, and enforcement are inherently applied for cloud application traffic. And application-specific traffic from any edge is automatically detected, so the traffic can be forwarded based on the network rules over the Cato global backbone to the POP that is closest to the cloud instance serving the business. This smart ingress capability optimizes the user experience. So there is no need to either use a regional hub that is close to your SaaS applications, but instead, just by riding through the Cato SASE cloud, you get both the optimization and the security needed to securely access cloud applications. Finally, Cato offers full visibility and control via flexible management model. A self-service console is available for customers to configure all policies and access detailed analytics and events. Cato and its partners can deliver a fully managed service for customers who want it. And regardless of management model, all of Cato software is fully maintained, enhanced, and secured by Cato and our engineers, SOC and NOC teams. The Cato SASE Cloud is a future-proof network for the digital business. As needed, Cato can be gradually deployed across use cases while coexisting with your current network and security infrastructure. So if you think about it, a WAN transformation is a journey, and this is how it could look like for you. You can start with SD-WAN for more bandwidth at a lower cost, like we mentioned. You can add a global backbone for your global sites and for optimizing connectivity into cloud data centers and cloud applications. You can deploy branch or cloud security or secure direct internet access solutions. Use cloud acceleration to enable cloud migration. Get a mobile VPN or SDP to support remote users, but you will never get a single management for all the capabilities, and you would not get this cost saving that we've mentioned in the fifth point about SD-WAN versus SASE. A SASE platform actually converges all the capabilities you need today and tomorrow. By contrast, a non-SASE approach forces you to find, evaluate, buy, integrate, and manage multiple products to cover each requirement. So just think again, how much time will you save by not doing all this work and just flipping a switch when you are ready? So what is the way forward after discussing SASE and SD-WAN so much? Solving one problem at a time is how complexity got out of control, right? We bought SD-WAN at one point, security at another one, cloud security at a third point. This is how complexity got out of hand. Taking a platform approach to your WAN transformation will address the challenges of today and prepare you for the opportunities of tomorrow. This is why Cato is the right choice for your business, because Cato, which is the world's first SASE platform, was built from the ground up to be a network for whatever's next. So thank you very much for staying with me for so long. I see some questions on the chat, so we'll go through them before we close. We have a question from, let me see, first one, Melissa from Hamburg. I am only interested in SD-WAN, not a full SASE. Why should I care about everything I don't need? Well, Melissa, that is a very good and also a very common question. So you can buy just SD-WAN, but again, you would lose by not gaining all the benefits of taking a platform approach to refreshing your wide area network. If you just buy SD-WAN, you would solve the point problem of your network today. But when you need to add security, cloud connectivity, remote users tomorrow or next year, that would be a complete new project. If you go with a platform approach like SASE, when you need to refresh your security, you'll retire your appliances and flip a switch in the SASE cloud and get the security from the cloud. When you need to enhance access for your remote users, you retire your VPN server or concentrator, flip a switch, and get ZTNA from the SASE platform on the same platform as your SD-WAN. So there is a lot of cost saving that might only happen in the future, but not today. But it is still something to consider when you look at transforming your network as a strategic approach and not a tactical, just solve my SD-WAN problem today kind of thinking. I hope that answers your question. Let's go to the next question. We have Alexander. I hope I'm pronouncing the name right, from Madrid. I like the vision of SASE, but I'm already invested in some of the major capabilities. How can I not pay double? This is also a very good and a very common question. Many enterprises have built their infrastructure over time, over multiple products, and as a result, the refresh cycles are not at the same time. You should look at SASE as a migration project that take time and that is a strategy that you're aiming to complete and to follow. And based on that, you only replace the components that reach their retirement point, so you avoid paying double. For example, your MPLS is at the end of the contract, you replace them today with an SD-WAN from SASE. Later in the year, you need to refresh your firewalls. You don't refresh them now. You keep your firewalls in place until they reach their end of contract. And when you get to the refreshment point, this is when you'll retire them and move the capabilities to the SASE. The same can go with private connections to the cloud, with remote access solutions. Anything you have today that you're already invested in should stay, and you should continue to use it until it retires, and then you move it to SASE. It's not an overnight rip and replace, and it shouldn't be. And if a vendor is forcing you to a full rip and replace, that means that the SASE platform they are offering you is not flexible enough to support a gradual deployment. And for you, that might not be the right SASE platform. Okay, I see that we're a little over 30 minutes now. So we have last question from Stephanie from Detroit. Cool. Everyone is saying they have a SASE today. How can I tell who is a real SASE and who is not? Wow, that's an excellent question that I will try to answer objectively, obviously coming from a SASE player. There are several factors on how you can evaluate SASE, but I think the best way to do is to go back to what Gartner defined as the core four capabilities of SASE. It needs to be converged, cloud native, globally available, and support all edges. Converged means that the networking and security are one solution. It's not one part for SD-WAN and another part for security that are separated either because they come from different product lines or through acquisitions. They really need to be one so that security and network can share the context. The second part is that it has to be cloud native, which means you need to consume the service as a cloud native offering like you do with Salesforce, with Workday, with Office 365. And if the SASE solution comes in form of appliances that doesn't have any cloud footprint, then this is not a real SASE. The third one is globally available. Again, if you're a global organization, the widespread of the SASE POPs is very important to you, and you should make sure that SASE is offered globally wherever your business is, and that the SASE POPs are within no more than 25 milliseconds round trip time from every edge of your network, whether it's a branch, a data center, or a remote users. And lastly, it should support all edges. And this is also a very important point, that the same platform should be able to connect both your branches, your data centers, your cloud data centers, and your remote users. If those are different products, even from the same vendors that you need to integrate, then this is not a SASE solution. This is an integration, and it's not any different than how we used to run IT until today. The fact that the same platform supports all edges means that you can avoid those integration, maintenance, and troubleshooting in different buying cycles and get everything from one platform. So to summarize, SASE has to be convergence, true convergence of network and security. It needs to be cloud native, not in form factor of appliances. It needs to be globally available from a global network of POPs, and it needs to support all edges in the same platform. If you speak with your SASE vendors and you get the confidence that it ticks all those four requirements, then I would highly recommend that you do a proof of concept with that vendor and make sure that they can actually prove in real life that all those capabilities and architecture requirements exist in the solution, and it's not just nice marketing slides. We recommend our customers to try our solution as well before they buy. I think that for any new technology, especially one that is destined to replace legacy technologies, a POC is a very strong recommendation. So we're exactly at 35 minutes. I want to thank everybody for joining today. Sorry that I couldn't answer the last questions from John and Francois. Sorry. We'll try and address those over email for you. Thank you very much for joining us today. Have a lovely day.